Hi, I'm Paul Kyogan from GK Tuition, and in this video I'm going through a Leave Insert Higher Level exam question. Now the question I've chosen to go through is 2015 Paper 1 Question 5. In the part A of this question, we're asked to solve x equals the square root of x plus 6. Now in this case you should recognize that my first problem is that I have a surd. So in order to get rid of the surd, I'm going to have to square the right hand side. But if I square the right hand side, in order to compensate for that, I'll also have to square the left hand side. So if I square the left hand side, I'll just get x squared. And if I square the right hand side, the square root and the squared will cancel, so I'm just left with x plus 6. Now you should recognize that you have an x squared, you have an x, and you have a number. So that means I'm going to bring everything to the left and it'll be a quadratic equation. So I'll just get x squared minus x minus 6 equals 0. Once I have a quadratic, I can now solve it and find the roots of this quadratic. So if I solve this, my factors will be x minus 3 and x plus 2. Once I have my factors, I can let each factor equal to 0 to find the roots. So I can say that x minus 3 equals 0, which means that x is equal to 3. And I can say that x plus 2 is equal to 0, which means that x is equal to minus 2. Now, whenever you got a question with surds in the top, I'd always go back and verify my answers. Okay, so let's verify the first one. So the first scenario, I want to see if this is true when x is equal to 3. So I can say that 3 is equal to the square root of 3 plus 6. So my first answer is that 3 is equal to the square root of 9. So clearly I'm ending up with 3 equals 3, so I'm happy enough with that one. So x equals 3 is an answer. Okay? And it's the next one that's interesting that I want to talk to you about. So the next one, let's sub in the next one. I get minus 2. So I would say if x is equal to minus 2, I'm going to sub that in. So on the left-hand side, it's just minus 2. And that's going to be equal to the square root of minus 2 plus 6. So my left-hand side, I got minus 2 is equal to the square root of 4. So now this is where this is really important, okay? Because I think some of you would probably say that is true, some of you would say that it isn't true. So I want to let me just explain this to you here, okay? You can say, I know that the square root of 4 is plus or minus 2, okay? Because think about it, I know that minus 2 squared is equal to 4, and I know that plus 2 squared is equal to 4. So I'm allowed to say that the square root of 4 is plus or minus 2. However, in the majority of cases when we're dealing with maths, we're usually only concerned with one answer. Like for example here, I didn't say that the square root of 9 was plus or minus 3. I just said it was plus 3. So in most cases we only take one answer. In the majority of questions, if I had the square root of 4, I would just say the square root of 4 is 2. Whereas actually the square root of 4 is plus or minus 2. Because this is true. Okay, so I can say that the square root of 4 is plus or minus 2. That's okay. I'm allowed to say that. And I can say that the square root of 4 is 2. If the question asks me for 2 answers, I'll just write this. If it asks me for 1 answer, I'll write this. However, if I'm only getting 1 answer, I cannot take the negative value. So in this case, I'm only getting 1 answer. I cannot say that the square root of 4 is minus 2. I can say the square root of 4 is plus or minus 2, or I can say the square root of 4 is 2. But you cannot say that the square root of 4 is minus 2. If you're only taking 1 answer, you have to take the positive one. If you're taking 2 answers, you can take positive or negative. But if you're only taking 1 answer, you have to take the positive one, and you can't take the negative one. So in this case, I'm clearly only taking 1 answer. I can't say that, I can't end up with minus 2 equals minus 2 here. I'm going to end up with, I have to get 1 answer, so the square root of 4 is just 2. So I'm ending up with 2 equals minus 2, so that's not true. So in fact, in this question, I only had 1 answer. My answer was x equals 3. Okay, so for the next part of this question, we're asked to differentiate x minus the square root of x plus 6. Now you should recognize the first thing that you would need to do here is try and rewrite your square root. It will be incredibly difficult to get the derivative of root x plus 6, but it's a lot easier to get the derivative if you write it as x plus 6 to the power of a half. So I just simplify first. But there's something else that we should do here. We need to be able to indicate when we've actually got our derivative. So in this line I haven't, I've just simplified. So if you should write this as y equals and what they gave you originally. And my next line now I can say y equals, and I've just simplified it. So I'm indicating that I haven't actually got the derivative yet. Whereas on the next line now I'm going to get my derivative, which means my next line is dy dx. So if I'm an examiner correcting your test, I can clearly tell that here you haven't attempted to differentiate. You've just simplified. Whereas now you're trying to differentiate. So I think it's just having the y and the dy dx on the left makes it a bit easier for the examiner. Makes it easier for the examiner, makes you more likely to get points, get marks. So the derivative, so I have x, the derivative of x is just 1. And I can use the chain rule to get the derivative of this. So I have a minus x plus 6 to the power of a half. So I can bring my power in front. So the power comes in front, it'll be a half times x plus 6, and then I decrease the power by 1. So a half minus 1, the power will become minus a half. So that's my chain rule. I had something to the power of a half, so the power comes in front, and it's all of that to the power of minus a half. And then I multiply by the derivative of the algebra. Or in other words, I multiply by the derivative of what's in the brackets. Which in this case, the brackets is just x plus 6, which means my derivative is 1. So I could have actually left the 1 out. But in this case, I multiply by the derivative of the algebra, so I multiply by 1. So we should always try and simplify it as much as possible. We can play around with our powers here to make this a lot easier. I have 1 minus, I'm going to write my half as a big fraction, 1 over 2. Okay? And I have to figure out what can I do with my x plus 6 to the power of minus a half. So let's play around with this for a minute. 1 over a to the power of p is the same as a to the power of minus p. That's one of my rules of powers on page 21 in my log tables. So if I have this to the power of minus a half, that's the same as 1 over all of this to the power of plus a half. So x plus 6 to the power of minus a half is the same as x plus 6 to the power of plus a half, as long as this is on the bottom of the fraction. And remember at the start we said that to the power of a half is the same as the square root, so I can actually write this, instead of having it to the power of a half, I can actually write that as the square root of x plus 6. So simplified fully, my minus a half times x plus 6 to the power of minus a half is 1 over 2 root x plus 6. It's just a lot neater like that, and it will make life easier for the next part of the question. Okay, so for the last part of this question, we're asked to find the coordinates of the turning point of the function f of x. Now, I know f of x is equal to x minus root x plus 6. And in part b of this question, I worked out that the first derivative of f of x is 1 minus 1 over 2 root x plus 6. You should recognize that to identify a turning point, you need to let the first derivative equal to 0. So to identify where the turning point is, I need to let my first derivative equal to 0. Or in other words, I need to say that 1 minus 1 over 2 root x plus 6 is equal to 0. And now all of a sudden I've got one equation, one unknown. I'm going to be able to find the value of x for which there's a turning point. So the first thing I should do here is subtract 1 from both sides, which means I get minus 1 is equal to minus 2 root x plus 6. Now, since there's a minus in front of both sides, let's just change the signs of the entire equation, and I get plus 1 is equal to plus 1 over 2 root x plus 6. Now, I suppose the next thing we should do is try and get rid of our fraction. In order to get rid of our fraction, we're going to multiply both sides by 2 root x plus 6. If I multiply the left-hand side by 2 root x plus 6, I'll just be left with 2 root x plus 6. If I multiply the right-hand side by 2 root x plus 6, I'm just left with 1. Okay, and now clearly my complication is that I've got a square root. So in order to get rid of the square root, I'm going to square both sides of the equation. So if I square 2, well 2 squared is 4. If I square the square root of x plus 6, I'll just be left with x plus 6. And if I square 1, 1 multiplied by 1 is just 1. So now I can multiply out my brackets and it's relatively straightforward. 4x plus 24 is equal to 1. Which means to get x on its own, I'm going to subtract 24 from both sides. And I'm left with 4x is equal to minus 23. Which means to simplify this fully, I just divide both sides by 4, and I can say x is minus 23 over 4. So now that's my x value. But make sure you go back and realize the question said find the coordinates of the turning point. To write down a coordinate, we need an x value and we need a y value. So now that I know, I need to find what is the corresponding y value when x is minus 23 over 4. So I need to sub in my x value into my original function and find the corresponding y value. So let's work our way through that now. Okay, so my original function was f of x equals x minus the square root of x plus 6. And I know that a turning point exists when x is minus 23 over 4. So to find the coordinate of the turning point, I need to find the corresponding y value. So you'll notice that I've just subbed in, instead of x, I've subbed in my value, and this one works itself out nicely, and I end up with y is equal to minus 25 over 4. So my final answer in this case, I know that a turning point exists for the function f of x at the coordinate minus 23 over 4 minus 25 over 4. So I hope this video made sense. If there's anything you're unsure of there, then just let me know in class or send me an email and I'll try and clarify it for you.